Okay, so today we're going to move on to section 7.5, day 2. And we're going to start with a question that most of you guys should know how to do at this point, especially if you've been using the graphing calculator to make our input-output tables. So basically what I'm asking you to do is I'm asking you to graph this exponential equation. Negative 2 times 3 to the x power, and then all of this is being added by 5. Okay? Still an exponential equation because it's a times b raised to the x power, but there's just a plus 5 at the end of it. Okay, so we can definitely use our graphing calculator here, and if you type this equation into that y equals menu, it should work out pretty well. But just so we're on the same page of what we're doing here, we're plugging in these x values into this equation and then plotting these points. So you would plug in 0 into this equation, which is negative 2 times 3 to the 0 power plus 5. You'd plug in 1, negative 2 times 3 to the first power plus 5, negative 2 times 3 to the second power plus 5, and then get some points on the negative side as well. Negative 2 times 3 to the negative first plus 5, and then negative 2 times 3 to the second plus 5. Okay, so the graphing calculator will do a pretty good job and do this pretty efficiently for you. You should get something like negative 13 right here, negative 1 right here, and I believe this is 3 right here. Okay, but what you guys might have noticed on like some of the ALEKS assignments is sometimes they don't like it when your y values are decimals. Okay, and the graphing calculator only gives you decimals, so we need to be able to do this by hand too if the situation arises. Okay, so let's do these negative numbers in our head. So if we have negative 2 times 3 to the negative first power plus 5, okay, that's kind of ugly, but let's just break it down piece by piece. The first thing we got to take care of is that exponent. 3 to the negative first power is the same thing as 1 over 3 to the first power, or just 1/3. So what this is really is, it's just negative 2 times 1/3 plus 5. Okay, order of operations means you got to do multiplication next. Negative 2 times 1/3 should give you negative 2/3. And then I want to add 5 to that. Okay, how do we add fractions? We got to get a common denominator. So what we have to change that to is negative 2/3. And then what I do here is I put this as 5 over 1, multiply the top and the bottom by 3. So what I'm really doing is I'm adding 15 over 3. And then I can just add straight across once I have that common denominator. Negative 2 plus 15 is 13 over 3. And the process is pretty similar to when we plug in negative 2. Okay, this should be negative 2 up here. 3 to the negative second power is the same thing as 1 over 3 squared, or 1/9. I'm adding 5 to that. Okay, you could try this on your own, but I'll fast forward a little bit. When you do the math, you should get something like 43 over 9, okay, or a number that's a little bit less than 5. Okay, now we're going to plot these points. Some of you guys still struggle with this, but let's start with the easy points first. Let's start with 2 comma negative 13. Okay, if I want to plot 2 negative 13, I have to go 2 units to the right, 13 units down, way down here, or even way off the page. 1 comma negative 1, 1 unit to the right, 1 unit down, somewhere like right here. 0 comma 3, right in the middle, but I go up 3. These fractions can be a little bit tricky sometimes. We just got to be careful when we're doing it. Okay, 13 over 3, if you want to plug that in the calculator, what you're going to realize is that 13 over 3 is basically just a number that's a little bit bigger than 4. It's 4 1/3. Okay, so what I'm going to do to plot that point, negative 1 for x, I go 1 unit to the left, and 4 1/3. So I go up 4, but not all the way up to 5, maybe just like a little bit above 4. Somewhere like right here. And then negative 2, 43 over 9. If you plug in 43 divided by 9 in your calculator, you get something like 4.77 repeating. Okay, a number that's still a little bigger than 4, but even closer to 5. If we plot it, it should be like way, way up here, but still below 5. Okay, and then after you have all these points, you play connect the dots, and here's what your graph should look like. It's going to stay below that 5 the entire time. Sorry for that little divot. But looks something like this. Okay, it'll flatline right around 5. Okay, They also ask for the Y-intercept and that thing called the asymptote again. We're definitely capable of solving for the intercept rather. The intercept is just whatever y is when x is equal to 0. So when we plugged in 0 in for x into this equation, we got back a y value of 3. This thing crosses the graph, or crosses the y-axis at 3. My y-intercept is equal to 3. Okay, asymptote's a little bit trickier, but I'll introduce this concept just so you guys are familiar with, because it's not going away anytime soon. Here's what the asymptote is. Every single time you make an exponential growth or decay graph, there's going to be some like imaginary number that the graph gets really, really close to but never actually crosses or touches. Okay, and if we look where this graph flatlines, it looks like it starts leveling out right at this point right here. Try that again. It never seems to cross that number 5. Okay, my graph is never going to go past that yellow line. Okay, so what the asymptote is they ask, what is the equation for this line that the graph gets really, really close to but never touches? Okay, it's a flat line in this case at the number 5. So the equation for that asymptote is y is equal to 5.